Hi there, I'm Hal, and this is just another video of me solving random numerical problem. Um, so unit task 2. So given an n by n integer array grid, and a robot is at the first cell, right top left, and we try to get to the bottom right here, and then we cannot include any obstacle in the path. Obstacle is 1 and 0 is space, right? So this is a binary matrix, only 0 and 1. So we need to return the number of unique paths. The robot can go from the top left to the bottom right. So the straightforward solution is we can use backtracking, right? So at any point in time, we can either go right or go down. So that is two paths. And then the length, the depth, right, of our recursion gonna be n plus n, right? Because you cannot go like this, right? And you can only go right and then down, right? Or down and then right. And so we give us the maximum depth of n plus n, right? Display is also n plus n due to the recursion stack, right? But we want to do better, right? So we can use dynamic programming through this. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's just do write out the number here. Right. 0, 0, right? Okay, so this is our given obstacle grid, right? So the DP at row and then column will represent what? Will represent the number of unique ways you can get, right, to this cell, right, or to this current cell, right, row and column, right? So DP at row and column means the number of unique way, the value, right? The value, right? Row column, the value of DP row column gonna be the number of units where you can get to this position, right? Yes, sir. So if it is the first cell, right? If it is not an obstacle, right? So let's say for example, if it is an obstacle one, right? So it would be a zero way, right? To get to the first cell, right? So you can set. We look at the grid, right? This is our grid, right? Just to be clear, right? We can update it in place so we can get a constant space velocity, right? But I'm just drawing it here to for easier to explain, right? So if the grid, right, is going to be 1, right, of the first cell, right, which means there's zero way to get to uh the first element, right? In this case, it is as 0, right? So you can set it to 1. So there's one way to get to the first cell, okay? So we can iterate from left to right, top to bottom, right? So in the second cell, uh, how many ways can we get to this cell? Two ways, right? Either from the left or from the top, right? Because you can only go right or go to the bottom, right? Go right or go to the bottom. So the ancestor are gonna be the left or the top, right? So you know that you can only get to the cell from either the left side or the top side. From top, and we just have to sum them up, right? Sum the number of unique ways you get from this from the left from the previous cell, right? And the total number of unique ways you get to the top cell, right, of the previous cell. But in this way, the top cell doesn't exist, right? So only okay. So seems similarly, there's no uh, left cell on the first column, right? There's no top cell for the first row, and there's no left cell for the first column. Right? So the number of unique ways of this cell gonna be equal to the number of unique ways you get to the previous cell. And because if we can get to the previous cell, which means we can get to this cell, and this cell is not an obstacle, right? So same here. So now we see an obstacle, right? Which means there will not there will be zero way to get to this cell, right? And now we are here, right? How many ways can we get to this cell? Well, two ways, right? This is the number of ways to get to this cell, right? The number of ways to get to the previous cell, which is top cell, right? If we can get to the top cell, then we can get to the current cell, right? Because the current cell is not an obstacle, so that's gonna be one, right? And then we're gonna check the left neighbors, right? And there's zero way to get to the left neighbors. So if we cannot get to the left neighbors, which means we cannot get to the current neighbors, right? Or the current cell. So this is just gonna be one, 0 plus one, right? It's one. So we need to sum them up. 0 plus one is one. Okay, same for here, right? So now we are here. We are in this cell, right? It is not an obstacle. So one plus zero is one, right? There's only one way to get to this cell because there's one way to get to the left cell, right? Which is this path, right? And then two, one plus one is two, right? Because we can get it to it from this way or this way, right? Because if we can get to the left cell, right, we can get to current cell. If we can get to the top cell, which means the top cell can go bottom, we can get to the left cell. So there's a two way. One plus one is two. And then we can just return this at the end, right? The last cell at the end. And that's pretty much it. Let's just code this up. Yeah, so we're gonna have row go to obstacle breakdown line, column go to zero line. And yeah, we will be able to return reduce the runtime to O of m multiplied by n, right? And because we need to visit every single cell only once, and then the display complexity gonna be constant because we gonna update it in place. Okay, and then we need to create our DP, right? Our DP equal to array like from the line is gonna be the row, and then another separate the line is gonna be column, and then we're going to return it at the end, right? The last step. We're going to return the number of ways we can get to the last there, right? The last at the bottom right there. Right, so we iterate from left to right, top to bottom. Okay, so we need to check if it is the first row, right? First column, first row, first column. Is it the first number, right? The first cell, right? Is it an obstacle or not? Okay, so we're gonna set the DP at the row. We're gonna be our DP table equal to something. Right? So the first thing, if it is an obstacle, right? We're gonna set it to zero because there will be zero way to get to the cell, right? If the cell is an obstacle, right? That makes sense, right? And first num, if it is the first number, right? Which means it is the top left. If it is the first number, which means there's no left neighbors and there's no top neighbor, right? So it's just gonna be one, right? Because if it is, so if it is the top left cell, right? And it is not an obstacle, which means that there's one way to get to this cell, right? Okay. And if it is not the first number, not an obstacle, then is it a first row? If it is the first row, right? There's no top column. So if it is the first row, there's no top neighbors, right? So we're just gonna equal to the left neighbor row column minus one, right? So the number of ways to get to this column, this position, right? Row and column gonna be equal to the number of ways to get to the left neighbors, the left cell, the previous cell, right? If it is the first column, right? Which means there's no left neighbors, there's only top neighbors, right? So, so the number of ways to get to this cell gonna be equal to the number of ways to get to the previous cell, which is the top cell here. So row minus one column, right? Uh, Otherwise, if it is not the first row, not the first column, not the first number, and not an obstacle, which means they are always two ways to get to it, right? From the previous neighbor, right, on the left and on the top. So we just add them together. And yeah, that's pretty much it. And thank you for watching.